Okay, more problems with CPCTC. This is a method that is, surprisingly enough, used often to measure distances that are difficult to measure. And we use congruent triangles to do it. So what you do here is when you get a problem like measuring this distance N to P, it's pretty difficult to drag something across the river. So what you do is you put a stake right here so that you know that NK is going to be perpendicular to NP, and then you find the midpoint between N and K, which is M, and then what you'll do is you'll walk so that we form another 90-degree angle here from K to L, and you want L to line up with M and P, so you have all three of those lining up. So again, locate point L so that L is perpendicular, or LK is perpendicular to NL, and so that L, M, and P end up being collinear. Now what's going to happen here is we're creating congruent triangles. And so the things that we know that, let me use yellow here, we know that these angles are congruent automatically. We know that NM and MK are congruent because, what's it called? Because M is the midpoint of NK. And then we can just go, this is a 90-degree angle, that's a 90-degree angle. So by angle side angle, these two triangles are congruent. That means that LK is equal to NP by CPCTC. So this length right here, which we can measure very easily, is going to be equal to NP, which is the measurement that we cannot measure. So it's kind of a cool problem, and you can use this just about anywhere. So again, this gives us what we have here, and we have our angle side, and because of the two angles right here being vertical angles, we know we have another angle there. So again, we know N and K are congruent. We know these are perpendicular, so we have right angles there. We know M is the midpoint, so NM and KM are congruent, and then the vertical angles are congruent, so the two triangles are congruent by angle side angle, and because of CPCTC, KL and NP are congruent, so these two lengths are congruent. If we measure LK, that's going to be the same as the distance across the lake, which is NP. And it says, does it matter how far from N you place the stake for point K? So let's go back. Let's see what they're saying. Does it matter how far apart these two are? And it really doesn't matter, because as long as there's a 90-degree angle here and a 90-degree angle here, and the distance from N to M is the same as the distance from M to K, these are automatically going to be equal, so we'll always have angle side angle in that case. So again, it doesn't matter how far N is from K, because M is the midpoint of NK. We have that given. We have both right angles being given, and we know that the vertical angles are congruent, so the two triangles will always be congruent. Okay? And again, no matter how far apart the should be the stakes are at K and M, we will always have two triangles that are congruent. And here's another type of proof. This is a pretty interesting proof. So we want to prove, given 1 and 2 are congruent, 3 and 4 are congruent, we want to prove BCE and DCE are congruent. So what we need to do, if we look at BCE is this triangle right here, and DCE is this triangle right here, we really don't have enough information right here. We know, let's see, we know CE is congruent to CE, and that's pretty much it. But we have an angle, we have a side. If we could prove that CB and CD are congruent, then we would have side angle side. So what we're going to do, instead of proving that these two triangles are congruent, BCE and DCE, what we're going to do is we're going to look at ABC right here and see if it's congruent to ACD. We're going to look at those two triangles and see if they're congruent, and then use CPCTC to prove that the two smaller triangles are congruent. So again, we can prove that this top triangle, ADC, is congruent to ABC because we have the two sets of angles, and if you look, AC is congruent to AC. So those two triangles are congruent by angle side angle. Once we prove the two triangles are congruent, then we know that BC and CD are congruent. We already knew that CE and CE are congruent. So then these two triangles are congruent by side angle side. I'll go through it in more depth. I know that's kind of confusing, just me talking about it. So again, what we do is for BCE and DCE, we know these two angles are congruent and that they have the common side that they have congruent. We need to show that CB and DC are congruent using side angle side. If we can do that, then we're set. So in between this, we need to look at ABC and ADC. And if we do that, we want to prove again that ABC and ADC are congruent, or CBA and CDA. We know these sets of angles are congruent, and again, that common side they have are congruent, so by angle side angle, those two triangles are congruent. Once we've done that, then we go back and we say, so we use the angle side angle to prove these triangles are congruent. Then we can state that these sides are congruent by side angle side. I'm sorry, yes, no, by CPCTC. And then we can use side angle side to prove that those two triangles are congruent. And that's it for this one. Thank you.